Okay, so I'm going to show you how to write your own equation and then balance it, because in the notes let me see, so you have notes and then you have the practice that I told you to do for balancing. Then you have this page, and there's also this page. I'm only going to have you do this page. So you can see that it says word equations. Write the word equations below as chemical equations and balance. Okay, so I'm going to show you how to do that. You always should know how to do that because you know how to take words and change them to formulas. But sometimes it gets a little confusing as you go along as far as writing them. So a couple things you got to keep in mind. You always have to keep your Braun-Cliffs in mind. You always have to keep your diatomic molecules in mind. So bromine, oxygen, hydrogen, nitrogen, chlorine, iodine, and fluorine, when they're by themselves only, it'd be Br2, O2, H2, N2, Cl2, I2, and F2. If they're in a compound, then they go by the periodic table and whatever charge they have. Bromine has -1, oxygen is -2, hydrogen positive and -1, nitrogen -3, chlorine -1, like that from the periodic table. So, but again, if they're by themselves, they're diatomic molecules, which means it's by itself, it's Br2, by itself, it's O2, by itself, it's H2, like that. We'll get there in just a minute. But let's do one that's a little easier first before we get into the Braun-Cliffs, which is down here. All right, so you have the very first one on your word equations worksheet. It says zinc plus lead 2 nitrate yields zinc nitrate plus lead. So zinc, just Zn, right? It's by itself, but it's not a Braun-Cliff, so it's just Zn, okay? Plus lead 2 nitrate. This 2 right here tells us what the charge on lead is. Remember that? So that means we have Pb plus 2. This is nitrate, polyatomic ion, NO3. And because, Delilah, I memorized my polyatomic ions, I just knew it was NO3. So drop your signs, cross them down. You get that, right? Okay. You might have to go back through that, figure out why. But again, Pb is plus 2. You know that because it says it right here. Nitrate is -1. Drop your signs, cross them down. You get PbNO3 too. Okay. Yields zinc nitrate. Zinc is one of those exceptions that's always positive too. But if you're not told about if you're not told about a transition metal, if you're not told what its charge is, it's always positive too. So that means that zinc is plus 2. Again, nitrate is NO3. I know that because I memorized my polyatomic ions. Drop your signs, cross them down. You end up with ZnNO3 too. Plus lead. Lead by itself is Pb. It's not a Braun-Cliff, so it's just Pb. Okay? Now, they were super sneaky with this one because it's already balanced. 1 Zn here, 1 Zn here. 1 Pb here, 1 Pb here. Here's a trick. See how you have NO3 here, and you have NO3 here, and you have 2 NO3s here and 2 NO3s there? If you have intact polyatomic ions on both sides, so you have NO3 on this side and you have NO3 on this side, that means that the N didn't break off and you go somewhere else, or the O didn't break off and go somewhere else. So you have NO3 and you have NO3. You can treat a polyatomic ion just like it's any other element and just count it as a polyatomic ion. 2 nitrates, 2 nitrates. See how nicely that works out? That means you don't have to go through the mess of saying there's 2 N's and 6 O's, there's 2 N's and 6 O's, right? You can do it that way if you want, but I'm just saying that's a little trick, okay? So this one is already balanced. We're good. Let's look at this one. Here's where our Braun-Cliffs come into play. Aluminum bromide. This is a compound. Aluminum is plus 3. I know that because I looked on the periodic table. Bromine is -1. I know that because I looked in the periodic table. This is in group 7. This is in group 13. Okay? Or 17, sorry. This is 17 and it's 13 if you're going to do it that way. So this is 7, this is 3, sorry. Anyway, drop your signs, cross them down. You get AlBr3, right? Plus, chlorine is by itself. itself, it's a Broncliffe, which means it's Cl2. Okay? See how it's by itself? Broncliffe, Cl2. Okay. Yields. Well, I guess I should put that down here because I started this. Okay. Aluminum chloride. Aluminum, again, is positive 3. Chlorine is negative 1. Group 7, group 3. Negative 1, positive 3. Drop your signs, cross them down. You get AlCl3. Plus bromine, Broncliffe. So Br2, correct? By itself, Br2. Okay? Now we got to balance this. Watch this. See, you have one aluminum here and one aluminum here. We're good there. You got 3 bromines here and 2 over here. You got 2 Cl's here and 3 over here. So it's the same thing. Okay? See how you have 3 and 2 and 2 and 3? It's the same ratio. So when you do this, when you put a 3 here to get 6 and a 2 here to get 6, you're going to do exactly the same thing with your chlorines. Your chlorine, in front of the 3, you're going to put a 2. In front of the 2, you're going to put a 3, because now you have 6 of both. Your aluminum magically balanced itself out. You have 2 aluminums here, 2 aluminums here. You have 6 bromines here, 6 bromines here. 3 times 2 is 6. You have 6 chlorines, 3 times 2 is 6, and 6 chlorines, 2 times 3 is 6. It's balanced. That's all you have to do. Okay? Try those. See what you can do. Writing your own word equations is going to be important in the next section, so it's a good skill to start working on. Again, if you have questions, send me a reminder. Okay?